Welcome to the era of autonomous orchestration, where neural networks negotiate at enterprise scale, necessitating a radical evolution in our fundamental understanding of machine identity and secure operational resilience. Today, we establish the definitive 2026 roadmap for securing the agentic economy by moving beyond human-centric protocols toward a robust framework of continuous verification for every single autonomous interaction. As global digital transformation accelerates the integration of frontier models into core business logic, becomes the primary vector for systemic risk remediation and high-value infrastructure protection across all industries. By mastering the principles of machine-to-machine zero trust, your organization will maintain a competitive advantage while ensuring that automated workflows remain resilient against sophisticated adversarial maneuvers in the digital landscape. We will deconstruct the architectural shifts required to govern autonomous agents, effectively ensuring that every API call and data exchange adheres to the highest standards of cryptographic integrity and authorization. This deep dive utilizes state-of-the-art research from the world's leading cybersecurity institutions to provide you with actionable insights for fortifying your enterprise against the next generation of automated incidents. Current research from the NIST AI Risk Management Framework in the United States highlights that the velocity of autonomous decision-making requires real-time risk assessment modules integrated directly into model layers. In the European Union, the ENISA Threat Landscape Report for 2026 emphasizes the critical need for trustworthy AI standards that prioritize the secure handling of inter-model communications within decentralized networks. Leading innovation hubs like Canada's Vector Institute and France's Mistral AI are actively developing interpretability frameworks that allow security architects to monitor agent behaviors without compromising the efficiency of neural processing. Across the Asia-Pacific region, the Cybersecurity Agency of Singapore has pioneered master plans for operational technology resilience that are now being adapted to secure the burgeoning machine-to-machine ecosystem globally. Latin American frameworks from CENIA in Chile and the OAS highlight the importance of bridging the connectivity gap while maintaining strict digital sovereignty through localized zero-trust implementation and training. Middle Eastern initiatives, led by the Technology Innovation Institute in the UAE, are pushing the boundaries of sovereign AI by embedding defensive logic directly into the foundation of Falcon-class frontier models. Inland research from Israel's Checkpoint Research underscores that the shift toward autonomous agents necessitates a complete overhaul of traditional firewall logic in favor of identity-based microsegmentation at scale. Collectively, these global benchmarks confirm that the end of the traditional perimeter is not a hypothetical future, but a present reality that demands immediate executive attention and strategic resource allocation. The fundamental challenge in 2026 is the explosion of autonomous agents that communicate directly with one another without any human intervention, necessitating an entirely new paradigm for identity management. Human-centric models rely on passwords and multi-factor authentication, which are fundamentally incompatible with the millisecond execution speeds and massive volume of requests generated by high-performance machine-to-machine networks and systems. To address this gap, we must implement machine-to-machine identity and access management frameworks that assign unique, cryptographically verifiable credentials to every individual agent operating within the enterprise ecosystem or cloud. These digital identities must be dynamic and contextual, allowing the system to verify not only the identity of the agent, but also its current state and its specific authorized purpose. By shifting to a robust machine identity framework, organizations can ensure that only verified agents can access sensitive data silos or trigger critical business processes within the automated production environment. This transition requires a move toward decentralized identity providers that can issue and revoke machine credentials at the speed of light, ensuring that compromised agents are isolated instantly from the network. Advanced identity frameworks also incorporate behavioral biometrics for machines by analyzing the typical patterns of agent communication and flagging any anomalies that suggest an unauthorized takeover or a logic breach. Ultimately, the goal of this shift is to create a seamless yet highly secure environment where autonomous agents can collaborate safely while maintaining a verifiable trail of every action taken. Legacy security protocols were designed to protect static networks with well-defined boundaries, but these models fail catastrophically when dynamic AI agents operate across fluid and highly distributed cloud-native architectures. In the 2026 landscape, the perimeter has effectively vanished as agents move fluidly between private clouds and public infrastructure, making traditional IP-based filtering and perimeter defense mechanisms largely ineffective for protection. When autonomous agents interact, they often bypass traditional inspection points, creating blind spots where malicious actors could potentially inject unauthorized commands or exfiltrate valuable proprietary data without detection by admins. The dynamic nature of AI workflows means that an agent's security context can change rapidly based on the task it is performing or the external data sources it is accessing. Legacy systems lack the granular visibility required to monitor these fleeting interactions, leading to a significant increase in the risk of lateral movement by unauthorized entities within the corporate network. Furthermore, traditional protocols often assume that once an entity is inside the network, it can be trusted, which is a dangerous assumption in an era of automated supply chain incidents. To mitigate these risks, we must move toward a software-defined perimeter, where access is granted based on the identity of the service and the specific requirements of the current transaction. This shift ensures that security follows the agent wherever it goes, regardless of the underlying network infrastructure, providing a consistent layer of protection across the entire hybrid cloud and edge. The implementation of zero trust for artificial intelligence starts with the core principle of never trust and always verify applied to every single packet and API call in the network. Within an automated agent network, this means that every request for data or compute resources must be authenticated and authorized using real-time policy engines that evaluate the risk of the transaction. Microsegmentation is a critical component of this architecture, allowing security teams to isolate individual agents and their workloads into secure zones that prevent the unauthorized spread of an adversarial event. Encryption of inter-agent communications is no longer optional, but a mandatory requirement to ensure that data remains confidential even if the underlying transit network is compromised by an external actor. Advanced API security gateways must be deployed to inspect the logic of machine-to-machine requests, ensuring that agents are not being manipulated into performing actions that violate corporate governance or safety. Continuous monitoring and logging of all agent activities provide the telemetry required to detect subtle signs of model poisoning or unauthorized prompt injections that could lead to a systemic failure. By integrating security directly into the AI orchestration layer, organizations can automate the enforcement of complex compliance requirements, ensuring that every interaction adheres to regional regulations like the EU Act. This proactive approach transforms security from a bottleneck into an enabler of innovation, allowing teams to deploy autonomous agents with the confidence that their operations are fundamentally secure by design. Practical defense in 2026 requires the deployment of automated response playbooks that can neutralize threats in milliseconds by deactivating compromised agents before they can cause significant disruption to the system. Organizations should implement mutual transport layer security for all inter-agent communications, providing a strong foundation of cryptographic identity and encryption for every interaction within the machine-to-machine ecosystem at scale. Standardizing on secure API protocols that include fine-grained access control and rate limiting is essential to prevent the exhaustion of resources and the unauthorized scraping of sensitive enterprise data assets. Regular adversarial testing of agent workflows using automated tools can help identify hidden vulnerabilities in model logic and communication paths before they are exploited by sophisticated actors in the field. Developing a comprehensive inventory of all autonomous agents and their associated permissions is a critical step in maintaining visibility and control over the rapidly expanding machine-to-machine surface area. utilizing threat intelligence, feeds specifically focused on AI-related vulnerabilities, allows security teams to stay ahead of emerging trends and patch their systems against the latest known adversarial techniques and exploits. Collaborating with industry peers and contributing to open-source security benchmarks fosters a collective defense posture that strengthens the entire global ecosystem against large-scale systemic risks and digital disruptions. Training internal teams on the unique challenges of AI-native security ensures that the human element remains a strong link in the chain of defense, providing oversight for autonomous orchestration systems. Imagine a global logistics firm utilizing a fleet of autonomous agents to optimize its supply chain and manage inventory levels across multiple continents in real time without direct human oversight or intervention. In this scenario, a specialized procurement agent must negotiate with a third-party supplier agent to secure critical components while ensuring that the transaction adheres to strict cost and quality parameters. Without a zero-trust architecture, a malicious actor could intercept the communication and redirect the payment or manipulate the order details, causing a significant financial loss and operational failure. By implementing the frameworks we have discussed, the logistics firm ensures that both agents verify each other's identity and authorization before any data is exchanged or any transaction is finalized. The interaction is encrypted and monitored by an AI-native security layer that flags the attempt at manipulation and automatically isolates the suspicious agent while notifying the Human Security Operations Center. This seamless integration of security and automation allowed the firm to maintain its operational velocity while effectively mitigating the risk of a high-impact incident that could have derailed its entire business. The synthesis of identity management and microsegmentation and continuous verification creates a robust digital immune system that protects the organization from the inside out in an increasingly complex environment. This real-world example demonstrates how zero-trust principles transform the potential vulnerability of autonomous agents into a secure and reliable foundation for the next generation of global enterprise innovation. The strategic ROI of investing in zero trust for AI is clear as it prevents costly disruptions and builds the digital trust necessary to participate in the high-velocity autonomous economy. As we look toward the remainder of 2026, the organizations that prioritize machine-to-machine security will be the ones that successfully navigate the transition to fully autonomous enterprise operations and growth. The trajectory of frontier models suggests that the complexity of inter-agent interactions will only increase, making the adoption of these defensive frameworks an essential requirement for long-term organizational digital resilience. By taking proactive steps today to secure your machine-to-machine ecosystem, you are not only protecting your current assets, but also laying the groundwork for a future of secure innovation. Turn knowledge into your greatest asset by applying these strategic frameworks today and lead the global innovation era. We walk the talk on digital trust. This content is 100% certified. Channel powered by generative AI architecture.